Now we discuss about a refraction of light. If a meter scale is placed in water, this is straight, but when it is placed in water, how it appears? Yes, it does not appear straight. Similarly, if a glass cube is placed on a printer material, the printed material appears to be magnified. Do you know what are the reasons for this? This is due to a property of light which is called the refraction. Now we discuss about what is the refraction and the different principles related to refraction. The bending of light ray when it passes from one medium to another medium is called a refraction of light. When light enters from one medium to another medium, due to change in density of the medium, the velocity of light changes. Due to this, deviation in the path of light occurs. Suppose we consider two mediums, medium 1 and medium 2, and this medium is less denser compared to this medium. This medium is called a rarer medium and this is called denser. When light enters from one medium to another medium, due to change in velocity of light, when it travels from one medium to another medium, it bends from its path. The same you can experience in our daily life also. Suppose you consider this marble is traveling straight. When suddenly the velocity increases, what you can observe? Yes, the path of this marble changes. Similarly, when light travels from one medium to another medium, due to change in its velocity, its path changes. This phenomena is called as the refraction. Using a ray diagram, how to represent the refraction? See here, this is a surface which separates two medium, medium 1 and medium 2. Medium 1 is rarer and medium 2 is denser. When light ray travels from one medium to another medium, it bends as are seeing in the figure. The point where light ray incidents, at this position, this MN is the normal. The angle between incident ray and this normal is known as angle of incidence. The angle between a refracted ray and normal, this is called angle of refraction. If there is no change in medium, the original path of the light ray is along this direction, but because of change in medium, the light ray deviates its path and this is the final path. Now this difference between final and initial path, this is called deviation. And this angle, the angle between incident ray and final ray, this is called angle of deviation. In this case, light travels from a rarer medium to denser medium. And we can observe that when light travels from rarer medium to denser medium, it bends towards the normal. In this case, the angle of deviation is I minus half. Similarly, when light enters from denser to rarer medium, now this is denser and this is rarer medium. In this case, in denser medium, the velocity of light is less. In rarer medium, the velocity of light is more. In this case, it bends away from the normal as we are seeing in the figure. This is incident ray. At this point, we are drawing a normal and this is angle of incidence, the angle between incident ray and normal. And this is angle of refraction, the angle between normal and refracted ray. And this is angle of deviation. In this case, the angle of deviation is R minus I. The laws of refraction are the incident ray, the refracted ray and the normal to the refracting surface at the point of incidence are lie in the same plane. See here, this is incident ray, this is refracted ray and this is normal to the refracting surface. These three are in the same plane. Another one is for a given pair of media and for the light of given wavelength, the ratio of sine of the angle of incidence and the sine of the angle of refraction is a constant. And this constant is called the refractive index of the material. And this law is known as Snell's law of refraction. That is, if I is angle of incidence, R is angle of refraction, sin I by sin R equal to constant. And this constant is known as the refractive index of the material. Now what is refractive index? Now we discuss about the refractive index of a medium. We know that light travels in form of waves. The characteristics of the wave are wavelength, frequency and velocity. And these three parameters are related with the equation velocity is equal to frequency into wavelength. When light ray travels from one transparent medium to another, a change in the wavelength of light occurs due to a change in density, more specifically optical density, considered with reference to the motion of light of the medium, but the frequency of light does not change. This results in the change of velocity of light when it travels from one transparent medium to another. For a given pair of media, the ratio of velocity of light in two media is constant, which is known as the refractive index of the medium with reference to another medium. That is, the refractive index of a medium. It is denoted by mu. This is equal to velocity of light in one medium by velocity of light in another medium. In general, the refractive index of a medium is defined as the velocity of light in vacuum to velocity of light in medium and mu equal to c by v. To calculate the refractive index of any medium, the standard medium, which is taken as reference, is air or vacuum. The velocity of light is greater in rarer medium when compared to the velocity of light in denser medium. For a given pair of medium, the refractive index is calculated for the denser medium with respect to the rarer medium. If V1 and V2 are velocities of light in medium 1 and medium 2, the refractive index of medium 2 with respect to medium 1 is mu21. This is refractive index of second medium with respect to 1. This is equal to V1 by V2. Now I am dividing with C and multiplying with C this equation. This we get mu12. This is equal to C by V2 into V1 by C. Already we know that C by V2, this is the refractive index of this medium, second medium, with respect to air or vacuum, that is mu2, and C by V1 is the refractive index of medium 1. Therefore, we can write mu12, this is equal to mu2 by mu1. What does the refractive index of a medium indicates? This gives an idea about how much the velocity of light decreases in that medium. For example, if the refractive index of glass is 1.5, then already we know that mu equal to c by v or v equal to c by mu, where v is the velocity of light in glass, c is velocity of light in vacuum, mu is the refractive index. Therefore, velocity of light in glass is c by mu, 1 by mu times of velocity of light in vacuum. Now this is equal to 3 into 10 power 8 meters per second. This is velocity of light in vacuum divided by 1.5. Now this gives 2 into 10 power 8 meters per second. Therefore, the velocity of light in glass is 2 into 10 power 8 meters per second. Similarly, if the refractive index of a medium is 2, then what does it mean? The velocity of light becomes 1 by 2 times in that medium. That means it becomes half. We take another example. The refractive index of glass is 3 by 2. The refractive index of water is 4 by 3. When glass is placed in water, then what is the refractive index of glass with respect to water? The refractive index of glass is 3 by 2 means this is the value of refractive index with respect to air or vacuum. The refractive index of water is 4 by 3 means this is the refractive index of water with respect to air or vacuum. Now when glass is placed in water, the refractive index of glass with respect to water is mu g with respect to water, that is W. Now this is equal to 3 by 2 by 4 by 3. Now this is equal to 3 by 2 into 3 by 4. We get 9 by 8. And according to Snell's law, the ratio of sine of angle of incidence and sine of angle of refraction is constant. This is refractive index, mu equal to sin I by sin R, or this is equal to C by V, where C is the velocity of light in vacuum or air, V is the velocity of light in that medium. Now we take the example when light enters from a rarer medium to denser medium. The light is traveling from rarer to denser medium. Let V1 is the velocity of light in rarer medium. V2 is the velocity of light in denser medium. According to Snell's law, the refractive index of second medium with respect to 1, that is denser medium with respect to rarer medium, this is equal to sin I by sin R, where I is angle of incidence and R is angle of refraction. Now this is equal to V1 by V2. Already we know that the velocity of light in rarer medium is more compared to denser medium, that is V1 greater than V2. Since V1 greater than V2, I greater than R. Therefore, we can conclude that when light travels from rarer medium to denser medium, it bends towards the normal. In this case, the angle of deviation d equal to I minus R. In this figure, this is the virginal path of the ray, this is the refracted ray, and this angle, the deviation between virginal and refracted ray, this is called angle of deviation. Similarly, when light enters from denser medium to rarer medium, this is denser, we consider velocity is v1, this is rarer medium, velocity of light is v2. In this case also, the refractive index of rarer medium with respect to denser, that is the refractive index of medium 2 with respect to 1, this is equal to v1 by v2, this is equal to sin I by sin r. Since v2 greater than v1, the velocity of light in rarer medium is more compared to denser medium, r greater than I. Therefore, we can conclude that when light travels from denser medium to rarer medium, it bends away from the normal. Now this is the original path of the ray and this is refracted ray, and the deviation between these two, this is angle of deviation. In this case, the angle of deviation is r minus I.